Great. Hello, everyone. Thank you for coming to this talk about Meta's next generation network switch, Minipack2 and Arista 7388X5. So my name's Shu Wang. I'm a hardware engineer at Meta, working on data center network hardware. And I would also like to introduce my co-presenter, Narayanan, who's a system engineering manager from Arista Networks. We will first have a quick overview of both switches, and then we will go into the details of both. Both Minipack2 and Arista 7388 are based on the modular 9-card architecture, which has 8 port interface modules. And they are using the latest Broadcom Tomahawk 4 25.6T switch ASIC with 512 50 gig PAM430s. And are targeting 200 gig FR4 QSFP56 modules. And as you probably know, each module comes with 4 50 gig PAM4 lanes. Since the early stages of architecting this generation of switch, we believed that it would be most power efficient to keep the SerDes rate consistent across from the switch ASIC to the optics wavelengths. So if you listened into the keynote speech yesterday, Broadcom's RAM talked about how Broadcom worked with us, and they took our feedback about that, and they came up with this Tomahawk 4 switch with 50 gig PAM430s. Of course, the advantage is we don't have to do any gearbox anywhere inside the system. And both switches can serve as the fabric switch, the level above the top of rack switch, and the spine switch in our F16 data center network. And both switches run FBOSS, our in-house or homegrown open network operating system. Now let's look at Minipack2. And this functional block diagram shows the data path, the control path, as well as the hardware management. We have the switch main board that hosts the switch ASIC and the run BMC module. And the PIM cards have the retimers, well, not gearboxes, retimers. 50 gig in, 50 gig out. It's from Broadcom, 7 nanometer, BCM87326. And we have a switch control module, which has the Mini-NIC COM Express module. As you can see, it's presenting all of our switches of this generation. And this is a front view of Minipack2. You can see the QSFP ports and the management ports. And from Minipack to Minipack2, we made an improvement on the system serviceability, where the switch mainboard is now a field replaceable unit. That's why we have a full release button in the rear of the chassis. Minipack2 is based on the same orthogonal direct architecture, same as Minipack, which opens up the airflow path for us to cool the optics easier. And we have a 65 degrees Celsius case temperature limit on the QSFP56 200 gig optics. Of course, it also shortens the tracements between the switch ASIC and the retimers. This modular PIM architecture enables us to explore different options for the port interface module, and it also reduces the failure domain when something like the QSFP DD connector fails or the retimer fails. Here is another closer look of the orthogonal direct architecture. If you recall, in Minipack, we have 64 differential pairs going from the switch ASIC to the gearboxes on the PIM. In this case, we need 128 differential pairs. And we also need something for the low-speed control signals. That's why we discussed with Amphinon. And Amphinon developed this XMX 8x17 orthogonal direct connectors to fit our needs. On the PIM itself, we placed all these QSFP DD ports belly to belly so that it's easier to cool the optics. Here are a couple of assembly views of the system. And you can see the SMB ejectors at the rear of the SMB module. We primarily support 200 gig QSFP56 optics, and the system is also forward compatible to 400 gig FR4 QSFP DD optics. And we also support the 100 gig QSFP28 optics as well. We just reduce the SerDes rate. This table shows the system power consumption under different inlet temperature and fan PWM settings. And our initial design target is 1.75 kilowatts under full line rate and typical conditions. And as you can see, we have achieved that goal. The most complex PCB in Minipack2 is the switch mainboard. It's a 14-layer PCB based on conventional single lamination with plated through-hole vias only. It has 14 signal layers and 6 power planes. We use Doosan, the deviant material for the high-speed layers, and we use this Faraday Flex embedded capacitance material for some of the power cores. This is an Allegro view of the SMB Signal Routing. Our ODM partner, Celestica, did a great job in routing this board, highly complex. You probably can see a lot of crisscrossing of the SerDes signals. That's for node balancing the different PIM slots to fully utilize the packet processing pipelines of the Tomahawk 4 switch ASIC. We adopted the RUN BMC form factor from the OCP to host the latest 8-speed ST2620 BMC chip. In the early days of the system bring up, we didn't have the system, but we already had the RUN BMC module. So we leveraged the RUN BMC evaluation board from a community member. And I think that showcases the power of collaboration at OCP. This is a photo of the PM16Q cards. And you can see the retimers, 4 Broadcom retimers, and one side of 8 QSFP-DD ports. The other side, we have another 8 QSFP-DD ports. We support multiple speed modes. There are certain rules when we have to mix the speed modes. That's primarily that's based on the capability of the switch ASIC. And we have the SCM switch control module. It has a different form factor than what we have in Wedge 400, Wedge 400C, but logically it's very similar. From Minipack to Minipack2, we improved the IOB FPGA. We added a USB interface from the BMC to the IOB FPGA so that BMC can talk to the IOB FPGA to do parallel flash upgrades on all of the PIM cards for their DOM FPGAs. Because in the previous generation, the speed of firmware upgrade was a pain point when we get the switches inside the data centers and do provisioning. We also upgraded the SLPC bus from 16-bit to 32-bit from Minipack to Minipack2. And here's a block diagram of the DOM FPGA. The AC/DC PSU and the fan trays are exactly the same from our previous generation. In summary, Minipack2 takes advantage of the latest Tomahawk 4 switch ASIC, supports 200 gig FR4 pluggable optics, and it enables our data center network upgrade from 100 gig to 200 gig based on the exact same data center infrastructure. Now I will hand over to Narayanan.
Thank you, Shu. Thank you for going into the details of Minipack2. Moving over to Arista 7388X5. 7388X5 was carefully designed and developed by Arista in partnership with the Meta team. Hundreds of engineers across both companies worked over the last 24 months. And most of this has been remote, and it's not been easy. So thank you for all the hard work and making these two products a reality. Now, 7388X5 shares all the key characteristics of Minipack2. And this was done deliberately so that the Meta team can use both these products interchangeably, but very efficiently. One such example is both products use the same rack mount kits. The port-to-port mapping to silicon is exactly the same. We've also adopted the OCP green touch points for operator efficiency. Overall, there are a lot of hyperscale benefits within this product. And as this product becomes generally available to the OCP community and all network operators, everybody can benefit from them. One such efficiency is power. The demand for data continues to grow, either because of AI, ML applications, or because of sheer need for more compute or storage. But for operators, the power budget doesn't increase. It tends to remain flat or maybe increase a little bit. And this product does wonders in this aspect. While the density and throughput doubles, the system power is pretty much 50% per gigabit compared to the previous generation products. While the power is reducing, the features are continuing to increase. The table scales are continuing to remain flat or increasing. New features such as VXLAN are going to get introduced in this product. Now, to use these features, you need a network operating system, and as Shu indicated, this product is going to support FBOSS. It will also support Arista EOS, the same single EOS binary that runs across all Arista products. Finally, this product is also SONiC capable. Looking at the product from a block diagram perspective, it's fairly simple, and this is in line with the Minipack2 as well. There's the switch main board, or we could call it the switch card, which houses the forwarding silicon. It's Broadcom's Tomahawk 4 in this case. You have the line cards, or the PIM modules. On the left is the management card, and on the rear are PSUs and fan modules. One thing that is missing from this block diagram is gearboxes and retimers, and that actually helps save a lot of power. Here's a front view of the system with 8 line cards. The line card in this slide is the 200 gig line card. It supports 16 ports of 200 gig, can also operate at a reduced speed of 100 gig. You can see the management module on the left, and then all the green dots are the ejector modules for the line cards or the management card. Here's a view of the 400 gig module in the chassis. Again, 8 line cards. Each line card supports 8 ports of 400 gig. This line card also supports MACsec and brings all the encryption features that one needs for inter-data center or intra-data center where the fiber is not under the operator's control. Now, both the 200 gig and the 400 gig line cards can be mixed and matched and operated at ease. Here's a view from the rear. You have the switch card module that can be removed from the rear. The ejector buttons help remove them, the green ones. The system is provisioned with 4 power supply slots. This is keeping future use cases in mind, but for all major use cases, 90% of them, 2 power supplies is still going to provide N+N redundancy. There are 5 fans to provide all the thermal cooling necessary for the system. I call this system as architected for hyperscale. The characteristics that hyperscalers generally want, the first one is product performance. This could be speeds and feeds, throughput, less power, very efficient. This product checks the box, so does Minipack. The next one that is very critical is reliability. We have strived to achieve reliability by keeping it very simple. The components that are getting used are made sure they are reliable enough, and the MTBF for this product is going to be in several 100,000 hours. Finally, the third one is serviceability. This is key. When hyperscalers are deploying thousands of these devices in their data center, serviceability is utmost critical. This product checks the box there as well. Every single line card, switch card, the supervisor, fan, power supply, everything is field replaceable. Hot swap is also supported. Of course, it only supports a single supervisor, so if you remove that, the system is going to go down. Now, there's the choice of line cards. Again, mix and match is possible again. Talking about the management module, the specs for this module is in line with Minipack2, and this is what helps. It provides the ease for operation. It is the same 8-core or the quad-core CPU with 8 threads, 32 gig RAM, 512 SSD, the Run BMC module with ASpeed AST 2620. It's pretty much in line with what Minipack2 does. And again, this is available for the OCP community to use. Optics. The main use case is 200 gig. So yes, 200 gig FR4 will be supported and 200 gig SR4 as well. While we talk 200, 400 gig is equally important for some customers. And this is where all the major 400 gig modules are going to be supported. The one thing that I want to call out is 400 gig ZR. The system is capable to support 64 ports of 400 gig ZR modules as well. This has been thermally designed and cooled to support that. And finally, yes, 100 gig modules, the most of the ones that one operators use are going to be supported as well. Looking from a system power and cooling perspective, most operators operate their data center at 30C, and if I have to say it's a cool data center, then maybe 25C, and if it's a hot data center at 35C. Even in these environments, a 128 port system, the total power consumption is about 1250 to 1275 watts. What this means is this is 10 watts per 200 gig module or per 200 gig port, including the optics. It is very efficient. If we compare this to previous generation systems, which were already efficient, it used to be 10 watts per 100 gig port. So it's pretty much 50% power efficiency with the system. Here's a picture of the power supply and the fan module. We have adopted supporting up to 277 volt input. This again brings more efficiency. It uses the high voltage AC input, and hence we have adopted the SAF-D connector. And on the right is the fans. These are the standard 2RU fans, but again, OCP green for touch points is being adopted here as well. In summary, the system is a high performance system supporting 25.6 terabits, supports 100, 200, and 400 gig speeds, allows the customer to choose the type of fiber plant they want or the optics and the radix in this case. You can populate all 8 line cards or use few depending upon how you want to grow. You can scale horizontally. MACsec is supported, as I called out. And finally, for flexibility, the choice of operating system. And from a feature perspective, the system supports all the hyperscale features one would imagine. Overall, the system has been defined for efficiency. The system has OCP green points and is green just because of its power and efficiency packed together. Call to action, Minipack2, I believe the specs are going to be submitted and along the complete design for OCP accepted this month. 7388X5 will be submitted for OCP inspired. Both products are going to be available in early 22. Minipack2 will be available via Celestica, versus 7388X5 will be available through Arista, and customer calls are going to be in early 2022. For more information, you can, for Minipack2, look at Celestica's website, and for 7388, look at Arista's website. Thank you so much for the opportunity and questions.
And if you have, for folks who are online, if you can just ask questions in the chat, we'll raise those up here. But then if you have questions in the room, please go to the mic so that folks online can hear.
You mentioned that Arista switch does not have any gearboxes and retimers. We've seen a lot of retimers in the designs of the Minipack2. Is that a difference?
That is a key difference, and that is the difference within the system design. While both systems share all the key characteristics, the one thing that 7388 doesn't have is retimers or gearboxes.
And how was that accomplished?
This was accomplished with flyover cables.
Okay, thank you.
And this is to Shu. With the Minipack1, you had an optical PIM. Do you foresee developing an optical PIM for the Minipack2?
Oh, that question. No, we cannot, or I cannot answer that question yet. Sorry about that.
We have a question online. Do you accommodate 64 by 400G just in case, or do you actually plan to use it? It seems that Facebook has been committed to Radix 128 on fabric switches. Does support for 64 by 400 signal that you will move back to Radix 64 in next generation data centers?
Well, the Radix 64 in this generation of the switch is really to be ready for interoperability with the next generation or the next generation of the switch based on 128 400 gig. The primary mode of this generation is 128 times 200 gig.
And another question from online. But again, if you have questions in the room, I'll interleave if I see anyone going up. What specific software does the 7388X5 ship with pre-installed? EOS, FBOSS?
That's a very good question. At this point, depending upon Meta's use case, it will ship with a certain firmware version where FBOSS can be loaded. And for customers who would want Arista EOS, it would get preloaded with Arista EOS. So both options are going to be available. And finally, the system also supports zero-touch provisioning. In today's world, everybody automates end-to-end provisioning, and the system is going to come up in that mode, and you'll be able to load whatever operating system you want.
Great. I think we're here at the end of time, so let's thank the speakers, and thanks for the questions.